Okay, let's look at example 4. Suppose that a production run of 200 circuit boards has 5 defective boards. 2 boards are randomly selected in succession for testing. Find first A, the probability that first and second boards are defective. So now think about this. We take out one board, what's the probability that it's defective? And then we take out a second board. What's the probability that is defective given the first one was defective? So here is a representation of the circuit boards. Suppose we remove one defective. What's the probability now that the second one will be defective? Now, before we get into the formula, just for a moment, let's figure out if these are dependent or independent. How do we know it's dependent? Well, the words that tell us that these are dependent events is the fact that we select 2 items in succession and that we're keeping them. So I take one item out and I keep it. Now my sample space has changed, so the probabilities will change. That means they are dependent events. So the probability of A and B equals the probability of A times the probability of B given A. The probability of A will be the probability that the first board is defective, and that will be 5 out of 200 because there's 5 defective boards in our batch of 200. Now, the probability of B given A. This is the probability that the second board is defective given that the first board was defective and it got removed. So let's think about that. We have 200 boards. We've removed one defective. So what's left? There's 4 defective out of 199 remaining boards. So now we can find the probability of A and B. We will just multiply our 2 values together. So the probability of A is 5 over 200 times the probability of B given A, which is 4 over 199. And the answer is 20 over 39,800. And if you want to simplify that, it will be 1 over 1,990. You can also write this as a decimal if you would like. Part B says to find the probability the first board is defective and the second board is not. We're still dealing with dependent events because the boards are selected in succession. So now let's think about this for a minute. We have 200 boards. The first board is defective, that is removed, and now we want the probability the second board is not defective. So we're going to use the same formula. Probability of A and B equals the probability of A times the probability of B given A. So the probability of A will be the probability that the first board is defective, and that will be 5 out of 200. Then the probability of B given A, that's going to be the probability that the second is not defective, given that we already removed the first one, which was defective. So I have 195 non-defective items, and because one item has already been removed, I'm left with 199 items total. So the probability of B given A is going to be 195 over 199. So now the probability of A and B is going to equal 5 over 200 times 195 over 199. So now I can just multiply these across the top and across the bottom. So the numerator becomes 975. The denominator becomes 39,800, and that simplifies to 39 over 1592.